What's up, guys? Today we're going to solve the minimum coin problem using dynamic programming. For those of you who don't know what the minimum coin problem is, quick little background on it. Basically, this question is asking if you had a pile of coins and your friend asked you to, let's say you were in the drive-thru and your friend needed like 27 cents out of your pile of coins, but you'd want to give it to him in as few coins as possible. So that's all that this problem is asking. So given a target value and a big pile of coins, how can you get that target value using the least amount of coins? So for today's example, we're going to be using coins with the values 1, 2, 3, and 5 cents. And we're going to be trying to get our target value of 9 cents. So dynamic programming is going to be, our answer is going to be based off of this table, which we will fill in a minute. But first, I'm going to explain why we chose to use dynamic programming. So we chose to use dynamic programming because of these two qualities right here, overlapping subproblems and optimal substructure. And for those of you who don't know what those are and what they mean, that's all right. Quick little explanation is if overlapping subproblems means that if you were going to try and write a recursive solution to this, so say instead of 9 cents we were going to try and solve for 97 cents, and you wrote a recursive problem that started with like 97 cents and then it split off into little branches and then that branch spread off into branches, you would actually end up solving the same problem multiple times later down in this tree. As you would get further down, you'd actually end up solving the same problem multiple times. So that's all that overlapping subproblems means, and the reason that dynamic programming is good for that, and the reason that we want dynamic program, if the problem has this characteristic, using dynamic programming will save us a lot of time because when we create this table, instead of solving the same problem many times down in this tree, we're going to be able to solve it just once in our table and then look it up when we want the answer. So optimal substructure is basically saying if you had like the optimal answer for something, or in this case, in this case, if we had like the minimum amount of coins to make, let's say 28 cents, and in that minimum to make 28 cents, we had the 3-cent coin, and we took it away, we would now have the minimum to make 25 cents. So that's all that this is saying for optimal substructure, that if you had the optimal answer for something and you took part of that answer away, you now have the optimal answer for that smaller value. And you may be thinking to yourself, that seems to always be the case, but there are certain scenarios in the real world where this is not the case, such as like flight pass. Once you say you were trying to fly from like California to New York and you had multiple layovers, once you take one layover out of the scenario, flights could end up cascading to where it would actually be more efficient to take different routes and have different layovers. So, but for today's example, we know that both of these properties are true, so we can fill out this table. So here's how I chose to set up the table, and there are different ways, but I'll explain to you the approach that I took to this, and then I will fill out the table with you. So each column represents the target cent value that we're trying to make at this time. So this value ranges all the way from 0 cents to 9 cents, and then in each row it is a factor of the coins we can use. So in the first row we can only use the 1 cent coins, and in the second row we can use the 2 and the 1 cent coins. And as you move down the table, so in this row you can use the 3, the 2, and the 1 cent coins, and then finally in the bottom row you can use all the coins available. And so what we're going to fill in the table is we're going to fill in the number of coins given the coins that we can use. So depending on which row we're in, given that number of coins and those coins available to us, what is the minimum number of coins needed to create this target value that we're looking for. So for example, if we only had the 1 cent coin and we were trying to create 0 cents, how would we do that? So obviously for 0 cents, which is our base case, you're not actually going to use any coins. And so now if we could only use the 1 cent coin and we were trying to make 1 cent, you would do that with 1 coin. So And then if you're going to do it with 2, obviously this becomes 2. And you see the pattern. Basically, at each spot in the table, you're going to look in the first row, you're going to look 1 coin back because you have the 1 cent coin available to you, and you're going to fill it in. So 1 plus that value. So to make 3 cents, you need 3 coins. And then to make 4 cents, we can look 1 spot in the table back, see it need 3. So now we're going to need 4 coins. We're going to need 5 coins to make 5 cents, and so forth. 6 coins, 7 coins, and then 8, and then finally 9 coins. So now when we get to this second row, we are now going to have the 1 and 2 coin cents available to us. But actually, since 2 cents is greater than the 0 and the 1 value, we can actually just fill these in on the table. Because 2's not adding 2 to our pile of coins isn't actually going to affect either of these answers because 2 is greater than it. So that doesn't really help us at all. So now that we have the 2 cent coin and we're here, we can look 2 spots back on the table because our value is 2 here. So we look 2 spots back on the table and we see it only required 0 coins to make that value. So we can add the 1 coin, which is the 2 cent coin, and we're going to have this value here. So in the same way, when we go to, we're trying to make 3 cents at this spot in the table, and we have the 1 and 2 coins available to us. So intuitively, we know that it's 2 coins. But if we follow the program and the kind of the approach we've been using, we can look 2 spots back in the table, 1, 2, and see it took 1 coin. So we also know it takes 2 coins to do it this way. So as you can tell, without even thinking about it, you can just look 2 spots back in the table. So like for the 5 cents, look 2 spots back and add 1 coin to that. And so it's a quick way to just fill in the table without actually having to do the math or think about it. All right. And so in the same way, now that we are using the 3 cent coin, we know we can't actually change anything that's before 3 cents, so we can just fill this in. And now, because we're trying to make 3 cents in this column, and we are now using the 3 cent coin piece, so we can look 3 further back. So 1, 2, 3. So you know this is going to be 1. And then when you go 1, 2, 3 spots back, 2. And so we can just fill this in, looking 3 spots back each time. So when we get to 7 cents, again, we're going to look 3 spots back. 1, 2, 3. And we add 1 coin to that because we're adding the 3 cent coin to that. So we're just going to be 3, 3, and 3. And again, now that we have the 5 cent coin, we know we're not actually going to be able to change this answer, so bring that down. And we're not going to be able to change this answer, so we can bring this 2 down. So now we're on the 5. And so we look 5 spots back in the table. It's because in this row, we're trying to create 5 cents, and we have the 5 coin available. So 1, 2, 3, 4, 5. And we see it required, obviously, 0 coins create 0 cents, but we don't even have to think about it. We just know that a 0 is there, so we can add 1 coin to that to make the value. So this requires 1. And so then in the same way, this is going to require 2. And then for the 7 cents, you're going to look 5 spots back. 1, 2, 3, 4, 5. So you know 2, 2, and then 3. All right, so now that we have filled out this table here, we are going to actually look at the code and see how it all works out and how it fits together. So, all right, so now that we are looking at the code, I've written the solution based off of the approach that we described on the table. I wrote it in C++, and for those of you who don't know C++, don't worry about it. I will be explaining it pretty much line by line, and the code will be in a GitHub link below, so you don't even have to worry about writing it. All right, so as I can tell you, run the code, and here's the table that we created previously when we were walking through the logic of the problem. And then it says minimum coins need to make 9 cents is 3. So everything checks out. Here is the basic, declaring the array of coins, declaring our target value, and then calling the function. So here's the function I wrote. Basically, right here, it takes in your array of coins and a target value. And right here, this variable is basically just figuring out how many unique coins we have. So in our example, we had 1, 2, 3, and 5 cent coins. So this is going to be 4. And then right here, we are creating, actually in the computer, we're creating the table that we filled out, which is a table which is, the 4 by 10 table. And you add the 1 here because you don't include the 0 in the target value. So you want to actually create everything from 0 to 9, not 1 to 9. So speaking of the 0, this for loop right here just fills in the very first column of the table with straight zeros. And we know that that's never going to change because no matter which coins you're using to make 0 cents, you need 0 coins. And so now we are going to create the table. So these 2 for loops right here, actually, and the third for loop in the middle, these are basically the code to do the logic that we did when we watched through the table. So for each coin, and then for each target value you're trying to make, we are going to update the table right here, looking at the previous spot. So like, for example, like when we were making this 2, we looked 1 back and added 1 to it. Or in this row, when we were using this 2, we looked 2 back and added 1 to it, and so forth. So that's all that this is doing, and I will actually explain a little bit more. This if statement is just making sure that the value in the table that we're looking at is greater than the coin value. So this was the thing that I said earlier, you're not going to be able to update, the minimum coins for 4 cents if you're using the 5-cent coin because it's greater than that. So we don't even have to check those cases. And then this for loop is actually just each time we find a new answer in the table, we're going to just write it all the way down. So we didn't do that in the example, but this just keeps the table at its most updated point every time you find a new solution. So if you're ever to have to end early for some reason, your table is as updated as possible. And then this line right here is pretty much the meat of the problem. And so it's just saying your current spot in the table is going to be equal to the spot in the table minus the value that you were using plus 1. So that's kind of every time you add a new coin, that is the minimum value for it. So this is just the logic that we were using with the table. And then this code right here prints out the table for you so you can see it, and then returns the value. So that is anything. As always, feel free to comment below if you have any questions or if you want to see a certain problem done. Thank you guys for watching, and until next time.